Okay guys, section 2.6, limits at infinity and horizontal asymptotes. Okay, so horizontal asymptotes sounds familiar, right? Remember we learned about what? Vertical asymptotes. Do you still remember what is called a vertical asymptote? If any one of those 6 situations, right, is met, then we call what? The vertical line x equals a is a vertical asymptote. What are the 6 situations? Do you still remember? If, when, what?
The function is undefined at that point.
Yeah, undefined. When x approaches a from the left, then what? F of x approaches to what? Infinity, right? So this is one case, one situation, right? Or when x approaches a from the left, okay, but f of x approaches to what? Negative, on the negative side, right? Or x approaches a negative, f of x approaches to what? Negative infinity. This is second case, right? Well, similarly, x goes to a from the right, f of x goes to positive infinity, or x goes to a from the right, f of x goes to what? Negative infinity, right? Or the other 2 cases are what? X approaches a from either side, from both sides, f of x approaches to what? Infinity, or when x approaches a from both sides, f of x approaches what? Negative infinity. Okay, so you can draw the pictures for all of these 6 situations. Okay, if any one of these 6 situations satisfied, we say this vertical line x equals a is what? The vertical asymptotes, right? Remember that? Okay, and then example guys, y equals 1 over x minus 3. Find the vertical asymptotes. Do you still remember how we did it, to find the vertical asymptotes?
You set the denominator equal to 0 and solve.
Yes, we let the denominator equal 0, we solve for x, right? So x equals, that number will be what? The vertical asymptote. Okay, so we say x equals 3 is what? The vertical asymptotes.
Now, how do you know if it goes to positive or negative? Can you go over that one more time?
Goes to positive or negative?
Yeah, can you tell?
Yeah, because see, when x approaches to 3 from the right, see for example, how about y? Y approaches where? 3 plus minus 3 give us 0 plus, right? So 1 over 0 plus positive infinity, right? Because 0 plus give us positive number. 1 is positive, 0 positive is positive, but 1 over 0 infinity, right? So see, this satisfies when x goes to a from the right, y goes to what? Positive infinity. So we say x equals 3 is what? The vertical asymptotes, right? So this is a review, okay, quick review for vertical asymptotes. Now today in today's class, we're going to do what? Horizontal asymptotes, okay? So after today we learn section 2.6, you should be able to find both of the vertical asymptote and what? Horizontal asymptotes, okay? So the main stuff for us is to find what? Horizontal asymptotes, okay? And we talk about limits at infinity means what? When either x goes to infinity or x goes to what? Negative infinity. This means limits at infinity means when x is either goes to infinity or x goes to negative infinity. Okay? Alright, so I'm going to ask the volunteer to read this definition for us. I want a volunteer to read this definition and also read this as well. Okay? Read all of this. Okay? Any volunteer? Simon, you want to read?
Okay. Let f be a function defined on some interval a to infinity, positive. Then the limit of as x approaches infinity of f of x equals L means that the values of x can be made as close to L as we like by taking an x sufficiently large. Alternate notation, f of x approaches L as x approaches infinity. Definition, let f be a function defined on some interval negative n negative a. Then the limit of x as x approaches infinity of f of x equals L means that the values
Okay, so one more definition, please.
Okay. Definition, the line y equals L is called the horizontal asymptote of the curve y equals f of x that equal either a limit of x approaches infinity, f of x equals L, or a limit of x approaches negative infinity, f of x equals L.
Very good, thank you so much, okay? So, horizontal asymptote is in this definition, okay? Before we look at this definition, let's look at the first two definitions, okay? The first definition is telling us, okay, when x approaches to infinity, if it doesn't say a negative infinity means x goes to infinity in the positive direction. Okay, so let's look at all of these figures, okay? So all of these graphs, okay, curves, this is the first curve. Okay, this is the second one. This is what? This is the third curve, okay? Any one of these curves, okay, tells us when x goes to positive infinity, how about the y value approaches to?
The limit.
L, right? Because this is a L value, right? This is L, and this is L, okay? Whatever the y value approaches L, y equals L, this horizontal line from the below, or y approaches L from above of the horizontal line, or y may, be intersect, y will go through L from either above or below, okay? All of these three cases tells us, okay, y approaches to L as x approaches to what? Infinity, okay? If this is the case, we say, okay, we'll have this limit, okay? What limit? Limit of f of x equals L when x approaches to what? Positive infinity, okay? So this and this, they're just alternate notations, okay? Yeah, so this limit, okay, if they're going to give you a limit like this, it looks like this, you have to know, what does this limit mean, okay? Well, for example, okay, if I say x approaches infinity, the limit of f of equals 2, can you imagine a picture about this limit?
You'd have a line that's approaching, that's going right and getting closer and closer to 2, but never quite reaching it.
Yes. That means, okay, in order to describe this limit, there are many ways to describe it. I use a dashed line, because this dashed line, you will see, it will be what? Horizontal asymptote for us, okay? So this is horizontal line, y equals 2, okay? When x approaches to infinity, y approaches to 2, right? So I will just give a very briefly picture, okay? This may not be the unique picture for us, okay? I'm just saying this picture gives us, limit of f of x equals 2 when x approaches infinity. But you can have different cases, okay? You can let y approaches, y equals 2 from what? From above, or just do this, right? Okay, so this is a definition for this limit, okay? Well, similarly, how can I understand this limit, okay? How can I understand it? This limit is telling us when x approaches to negative infinity, y value approaches what? Value L, okay? See? X goes to negative infinity, y value approaches to what? To L, okay? And both of this limit and this limit, okay, we call them what? Limits at infinity. Why? Because these are the when x either approaches infinity, what while the y value approaches to, right? This is when x approaches negative infinity, what y value approaches to. So both of these two definitions, okay, about limits, okay, the limits, they tell us limits at infinity. Okay, when we talk about limit at infinity, that means let's find the limit of the function when x either goes to infinity or x goes to what? Negative infinity. Okay. Okay, now we're okay for these two definitions. Okay, so very naturally, horizontal asymptotes. Okay. So if a curve y equals f of x satisfy either one of these two conditions, what are the two conditions?
If it approaches negative infinity or infinity.
Infinity, the y value approaches to L, then we'll have a horizontal line. Have you noticed this horizontal line? Have you noticed this? Horizontal line, y equals L, horizontal y equals L, horizontal line. Well, similarly, in these cases, we have these horizontal lines, y equals L, okay? And then this horizontal line, y equals L, is called what? Horizontal asymptotes, okay? Well, you may ask, okay, oh, we know that horizontal asymptotes, okay, the definition of it is either one of these two definitions satisfies, right? So how can we find horizontal asymptotes for a given function? How? We just need to find the limits, right? What limits? Either that what? X approaches to infinity, let's check the y value. Or that what? X goes to net infinity, we check the function's y value, okay? Then that y value will be what? Give us a value, right, L, and then we let y equals that value L will be the horizontal asymptotes, right? So let's look at this example, everyone. What is the limit of 1 over x when x approaches infinity? What do you think? 1 over infinity. 0, right? 1 over very, very large infinity number, but this infinity number is negative number. Does it matter? No. Yeah, 1 over net infinity is still 0. Because net infinity also is a very huge number, right? Even if it's a negative number, but it's a huge, huge number. So 1 over that huge number still gives us what? 0. Okay? Okay, so both of them satisfies, okay, the limit equals 0. So this is an L value, right? L value. So what conclusion can we get?
There's a horizontal asymptote at y equals 0.
Y equals 0 will be the horizontal asymptotes. Okay. Right, everyone? So now this example is telling us how to find a horizontal asymptote. Find the limits. We just need to find one. Well, we have to find two, okay? Sometimes, okay, the limit when x goes to infinity and the limit when x goes to net infinity, they may be different, okay? I'm going to show you an example, okay? Sometimes we may have more than one horizontal asymptotes, okay? And sometimes we may have more than one vertical asymptotes. It really depends. Well, see example, this curve. When x goes to positive infinity, it approaches to what? Say number L1, y approaches to L1. When x approaches net infinity, y approaches to what? L2. So how many horizontal asymptotes do we have? 2. Okay, so you say y equals L1 and y equals L2 are both horizontal asymptotes. So to find horizontal asymptotes, we have to do both limits. Well, for this example, both limits, they're equal to the same value. So we say just one horizontal asymptote. But a lot of times, we may have more than one horizontal asymptotes. And at most, how many horizontal asymptotes? At most 2. Why? Because we only need to find what? 2 limits. So at most 2 horizontal asymptotes. Okay? Alright, so we have this rule 5. Okay, it says if n is a positive integer, what does positive integer mean? N could be 1, right? So what, if n equals 1, we have what? 1 over x, right? And when n equals 2, what can we have? Okay, I'm going to write this in a more specific way. If n equals 1, okay, limit x approaches 0, 1 over what? X, because n equals 1, okay? Well, equals what? 0, we just did it, right? And limit when x approaches net infinity, 1 over x will equal what? 0. Okay, so this is like a more specifically, okay? Because n could be all positive integers, so you can do infinity of them, okay? So when n equals 2, x approaches infinity, x 1 over what? X squared. See, when n equals 2, we have 1 over x squared. How about this limit? Equals what? 0. Because when x goes to infinity, how about x squared? X squared will also go to infinity, right? So 1 over infinity, 0. How about when x goes to net infinity, 1 over x squared? 0. Okay, well, if n equals 3, same thing. X goes to infinity, 1 over x to the cube. What do you think, this limit? 0. X goes net infinity, 1 over x cubed equals what? 0. So, you may choose n to be any positive integer, okay? It will always satisfy this conclusion, okay? This conclusion is always true. 1 over x to the nth power. N could be 1, could be 2, could be 3, could be 4, could be 5, could be 100, could be 1,000. This limit is always equal to 0, okay? When x approaches infinity, or x approaches to negative infinity. Why? Because on the denominator, x to the nth power will always approaches to what? Either positive infinity or negative infinity, right? When x approaches to infinity or negative infinity. So 1 over the infinity or negative infinity, or 1 over negative infinity will always give us what? 0. Do you see that? This is so important that you will see it will help us to solve for some limit questions. Okay, this example is so good. Okay, so let's try it. Yeah, let's do this one. Okay, compute the limit of this rational function when x approaches to infinity. X approaches infinity. 3x squared infinity. 5x times x squared goes to infinity, so infinity over infinity. Can we say there's no solution for this type of problem? How to solve for this type of the limits? If we have a polynomial divided by a polynomial, what do? Our idea is find the highest power from the denominator. What is the highest power of x from the denominator? 2. So, because x squared is what? I would say the leading term for this polynomial, x squared. The 2 is the highest degree, okay, highest power for the x. So, for solving this type of problem, what do? We're going to always divide the highest power of x from what? The denominator. I'll show you more example, you'll see, okay? So from this example, we have x squared. So what we do is, we're going to divide both of the top and the bottom by what? X squared. Okay, so I'll show you. Limit x approaches infinity, okay? On the top, okay, 3x squared minus x minus 2 divided by x squared, okay? Where does this x squared come from? Denominator, highest term, okay? Highest degree term. Right? 5x squared plus 5x plus 1 divided by x squared. Okay. Equals limit x goes to infinity. 3 terms divided by 1 term. 3x squared divided by x squared gives us what? 3. Negative x divided by x squared. Negative what? 1 over x. Do you see that, guys? Negative x over x squared. What? Negative 1 over x. Do you see that, Simon?
Well, it cancels, yeah, I see that.
Negative 2 over x will give us negative 2 over x squared, right? 5x squared divided by x squared. 5. 4x divided by x squared. Plus 4 over x plus what? 1 over x squared. Right? Alright, now let's apply the limit and see what we can have. Limit when x approaches infinity of 3. What do we have? Constancy is 3, right? What is the limit of 1 over x when x goes to infinity? What is it? 0. What is the limit of negative 2 over x squared? 0. Constant 5 is 5. Limit when x goes to infinity, we'll have a constant 5. We don't have x involved, it is 5. How about the limit of 4 over x when x goes to infinity? What do you have? 0. 1 over x squared limit give us what? 0. So eventually, we have a what? 3/5. Does everybody see this? Okay. And then there is a way for us to compute this type of limit by what? Find the highest degree term from the denominator, divide it from top and bottom, same thing, okay, same term, okay, x squared, okay, we don't have to worry about the coefficient 5, okay, just divide by x squared only, okay, and then simplify and then find the limits, okay. All right, now let's move on, okay. I really want us to practice more, okay, so I will give us some actual examples to practice. It's just an example, okay? Find this limit. For this example, what should we do? How? What? Yes, highest power in the denominator is x squared. So what we do is to divide by x squared from both top and bottom. I'm going to write it like this, in this way, so hopefully you guys can see better. Both top and bottom divide by x squared. Oh, limit. On the top we have what? 1 over x, right? 6 over x squared. On the bottom, what do we have, guys? 2 minus 1 over x plus what? 3 over x squared. Plus?
Yes, plus.
Yeah, plus. We just need to take these signs, right?
Sorry.
Okay, now let's check the limit. On the top, limit of 1 over x when x goes to infinity give us what? 0. How about 6 over x squared? X goes to infinity? 0. Constant 2? 2. How about this limit when x goes to infinity? 0. How about this limit? 0. So eventually we have a 0 over 2. What is it? 0. Okay? Well, you guys, let's check. Highest power from the numerator is 1. Highest power from the denominator is what? 2. 1 is less than 2, right? So eventually the limit give us what? A 0. So we say what? Y equals 0 is going to be the horizontal asymptote for us. Okay? And from the previous question, I believe you learned this in your Math 136 college algebra. 3x squared, 5x squared. Both top and the bottom, they have the same highest degree. X squared, 2, right? So eventually, what is the horizontal asymptote for this function? 3 over 5, but we only choose a coefficient, right? Okay? Next question. This function, on the top, the highest power is what? Greater than the highest power from the bottom. Let's see what conclusion can we get. Can you imagine? You still remember? Let's do it, okay? This time we should divide by what? X. Always divide the highest power from the what? Bottom. 2x squared minus x plus 3 divided by x. X plus 6 divided by x. X squared divided by x. Negative x over x. 3 over x. X over x. 6 over x. let's see what we will have, okay? 2x, x goes to infinity. Yeah, negative 1 is a constant, we keep it. 3 over x, x goes to infinity, 0. Constant 1, 6 over x, 0. Now let's see. Infinity minus 1 plus 0, still infinity. 1 plus 0 is what? 1. So what is infinity over 1? Infinity. Okay? Now if we summarize all of these cases, okay, for compute the limits of what? A polynomial over polynomial, there are 3 cases. One case is if on the top, the highest power is less than the highest power from the bottom, y equals 0 will be the horizontal asymptotes. If both top and the bottom, the highest power is the same, then y equals the coefficient divided by coefficient 3 over 5 in this problem will be the horizontal asymptotes. Third case, if on the top, the highest degree is greater than the highest degree from the bottom, will we have a specific value for this limit? No. So we say there's no horizontal asymptote for this function. You learned this in Math 136. I taught Math 136 many times, so it's just a refresh, okay?